In order to concatenate two lists, we actually can use the same plus sign that we did when we were concatenating tuples. And here we're going to show a couple of other methods to accomplish the same thing. So right here what we've done is created a list 1, which is 2 strings, and a list 2, which is 2 integers. And then we create list 3, and within list 3 we combine these two other lists, right? List 1 and list 2. Let's run this. You've seen this before, so it's nothing special. Now, we can actually use the extend function to do kind of the same thing. Here we're creating another list, pig and dog. It's a list of strings, and we're saying, look, take and extend list 3 with this list that we've written on the fly here inside this extend function. So we used append before. I mean, another way to think about this is you can use extend to append more than one item, but those items have to be in a list, right? So if we run this extend function now and re-inspect list 3, we find that now we have extended list 3 with another list. So can you see the similarity between just using a plus and using the extend? Now here we have simply extended list 3 on the fly, like we said, just by creating a list inside this function, but we could also grab a pre-existing list. Here we've created another one, list 4, with a string and a integer, and instead of extending and creating this list on the fly, we're extending with a pre-existing list, and that also works. And so these are 3 equivalent ways of going about the same thing, although you will find that extend has utility beyond what this simple concatenation does. Now, sorting lists is interesting. We have a list here of integers that is not sorted, but if we run the sort function on it, it's just a simple dot sort. It'll put those in order according to numerical value. Well, what if we have a list of strings? It will sort these as well, but it'll sort them alphabetically rather than numerically. So this runs from C, D, and E, and right, so we can see they're alphabetically sorted. This sort here, it has no parameter inside it, but if we put a parameter inside there, we can sort by some condition. And there are different keys that we can sort by, but we're in this instance we're sorting by the length of the item. Now, by inspection, I would have to count these up to know whether elephant was longer than dinosaur. I mean, it's very easy to see that pig is probably going to be the first item in this list after we sort it. But in order to see the last element, it's going to be easier just to run this than it is to count all those letters. All right, here we find out that elephant is actually longer than dinosaur because it's the last item. We could actually add reverse equals true to this. Now, if we want to reverse these to where the longest one is first, we can just simply jump in here and we can type in reverse equals true. Run that again, and then elephants is going to be first and pig is going to be last. Now, related to this sort function is also a sorted function. And using a sorted function, we can actually sort by multiple columns, or by multiple conditions, I should say. And right here we've just put key 1 and key 2. So inside this student's tuple, we have 3 other tuples, and item 1 in these tuples is supposed to represent a score from a grade, and this is an age. So item 1 and item 2, and we can sort inside this tuple that way. What we're saying inside here is sort by the grade first and sort by the age second. So let's run this tuple, and now that's been created. You see we've got an outside tuple, and inside we have 3 tuples. And another interesting thing that sorted does over sort is that this outside structure is going to be converted into a list rather than a tuple. So let's just run that. And we see that it's reorganized these. We have the lowest grade first and the highest grade last. So we've sorted first by key 1, and then it sorts by the age as a second condition.